Hey everyone, I want to start off this video by asking you to pause it and write down these 5 steps for solving inequalities if you're using notebook paper for these notes. So if you printed this, then great, don't worry about it, but if you're using notebook paper, if you could take the time to copy these down, that'd be awesome. Alright, so what we're going to do is we're going to look at 2 of these 4 problems, and then I'll leave the other 2 for you to try, and I'll upload scans of the actual answers. We're going to look at number 2 and number 4. Alright, so number 2 is secant squared of x less than or equal to 4/3, and we want to solve this within the interval from 0 to 2 pi. Okay, actually we want to include 2 pi in this. Brackets on both. Okay, look at the steps, right? Step number 1 says to get all of the terms on one side. So we're going to move everything to the left. Right, so we have secant squared of x minus 4/3 less than or equal to 0. Okay, so that was step number 1. Check. Step number 2. Write the non-zero side of the inequality as a function. So this left-hand side, we're going to give it a name. I'm going to call it f of x. And that's it. Step number 3. Find all of the zeros of the function and anywhere where it's undefined. All right, so the zeros, we're going to have to set this function equal to 0 and solve, right? So if we do that, we would add the 4/3 over. We would have secant squared has to equal 4/3. We're trying to solve for x, so we want to get rid of the square. Let's go ahead and take the square root of both sides. That gives us secant of x equal to, and then you remember what you have to put when you take the square root of both sides of an equation? Plus or minus. All right, so we're going to put plus or minus. Square root of 4 is 2 over the square root of 3. All right, now what? Turn it into a cosine. All right, turn it into a cosine equation. We can do that so easily, right? If we just flip the fraction on the right-hand side, we get that cosine has to equal plus or minus square root 3 over 2. And then you want to ask yourself, where does this happen, right? So where does cosine equal plus or minus square root 3 over 2? Well, if you think about it, it's going to happen at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, so how could we write that in a simple way? Well, we could say, you know what, actually since we only care about this interval, I'm not even going to worry about writing it with k's for this problem, because I'm solving for x directly right here. So we can just put the solutions down. We have those 4 solutions where I started to draw them out where they were located on the unit circle, right? Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right. Moving on, if you look at step 3, it also says to find where the function is undefined. Okay, so is this function ever undefined? So you want to think, all right, it has a secant in it. Are secant functions ever undefined? Think about their graphs. Do their graphs have asymptotes in them? Or does its graph have asymptotes, a secant graph? It does, right? And the reason that it has asymptotes is because secant is 1 over cosine. So really this is 1 over cosine squared minus 4/3. Now what would make this undefined would be if cosine squared equaled 0, right? Or if cosine equaled 0, right? Because we could take the square root and get rid of that square. So where is cosine equal to 0? Between 0 and 2 pi, where is cosine equal to 0? Where's the x-coordinates on the unit circle 0? That happens at pi over 2 and 3 pi over 2. Okay, that concludes step 3. Moving on to step 4. Put the solutions from step 3 on a number line and create a sign diagram. All right, so I'm going to squeeze step 4 down here. So we're making a number line. We want to put these values, all of the answers we got from step 3, on this number line in order. So we have pi over 6 is the smallest. Then pi over 2, right? Then 5 pi over 6, which is in the second quadrant. Then 7 pi over 6, which is in the third quadrant. Then 3 pi over 2, which is the bottom of the unit circle. And then 11 pi over 6, which is in the fourth quadrant. There we go. And we want to decide, do we want to include these values in our answer, or do we want to not include them in the answer? And it depends, right? The values that make the function undefined are definitely not included in the answer. They're never ever going to be included in the answer because we're looking for where the function is less than or equal to 0. So if the function is undefined, it's definitely not less than or equal to 0. Now what about these? These are the zeros of the function. Should they be included? Sometimes yes, sometimes no, and it depends what we're looking for, right? We're looking for less than or equal to 0. So since we are allowed to equal 0 here, right? We're looking for where it equals 0. We do want to include the zeros. So I'm gonna make these closed in. Okay, and then we're ready to test values. And you know what? I did make a little mistake. I'm used to when I build these sign charts. Yes, especially in college algebra, we build a lot of them, and normally they keep going on the ends. But I forgot, we're in this interval here, right? Only from 0 to 2 pi. So really this has a starting point and it has a stopping point. Starting at 0, ending at 2 pi. All right, so next, we're gonna do our test values. I suggest for this, actually using the calculator to get answers, okay? So I'm gonna grab my calculator. Hold on, I'll be right back.